Hello, today we continue to calculate the complex uh, questions in the trigonometries. And here you can see in the figure we have a solid and formed by cutting out the pyramid VABC from a cuboid. And we know that this is 12 cm, EF is equal to FG is equal to 10 cm. And also EB is equal to CG, it is 4 cm. Firstly, we need to find out the length of AB, AC, and BC. And also we need to insert form. Firstly, we find the AC first. AC, which is the red line here. If we find the value of AC, firstly, we need to focus on the triangle VAC. The triangle VAC, and here we can see it for the line AV, it is 12 cm. And for the line VC, it is 10 cm minus 4 cm because the whole line it is 10 cm for the VG. And we need to find the VC, so here it is 10 cm minus 4 cm. And here we can use the Pythagoras theorem to calculate the answer because it is the cuboid, and here it is perpendicular and 90 degrees. So we can find the AC by Pythagoras theorem. It is 12 square and plus 10 minus 4 square, and we take the square root. So we use the calculator to find the answer. It is 6 times square root of 5 cm. And firstly, the answer of AC is this one. And then we calculate the length of AB. For AB, we focus on the triangle VAB. As you can see here, the triangle VAB here, it is also 90 degrees. It is also the perpendicular from AV to VB. And for the line AB here, we use the Pythagoras theorem. For AV, it is 12 cm square and plus the VB also it is 10 minus 4 square. And we also have the answer. It is 6n times square root of 5 cm. This is the length of AB. And lastly, we calculate BC. For BC, we focus on the triangle VBC. The triangle VBC. And here, as you can see, in the VBC, also it is perpendicular to each other. We also use the Pythagoras theorem to calculate the answer of BC. So firstly, we take the square root. And you can see here, for the line VC, it is 10 minus 4 square. And we plus the line VB. It is also 10 minus 4 square. And we have the answer 6 times square root of 2 cm. And this is the answer of BC. And for second questions, we need to find the total area, the total surface area of the solid. And here we can divide it into a few parts. And first part, it is the area of HACG is here, this one. So first, HACG. And it is the trapezium, so we will have 4 plus 10. 4 is here, plus 10 is here. Upper side and lower side, and we multiplied the height, HG, it is 12 cm, and then over 2. We have 84 cm square. It is the first part. And for the second part, we calculate the area of ADEB. ADEB is this part. And for this part also, it is the trapezium for ADEB. We have the upper side and plus the lower side, 4 plus 10, and also multiplied 12 cm. It is the height, and over 2. We also have the same answer, 84 cm squared, because these two are the same size trapezium. And next one, we have the area GCEF. This one. For this one, it is also the trapezium. We have the upper side 4. Sorry, we have the area GCEF. Upper side 4 and lower side 10. And also, we multiplied our 10, the height, and over 2. Oh, for this part, we can use other method to calculate it, and we just remove it first. Now with this part, we can firstly calculate the whole area of the rectangle VGFE, and then we minus the area of the triangle VBC. It means that for our whole area of this part, it is 10 times 10. It is the square. Yes, the square, not the rectangle. And we minus this part. This part, it is 6 cm times 6 cm and over 2 because the triangle. And we have the answer, it is 82 cm squared. And then for next part, we need to calculate is the orange part. As this part, it is the area of triangle ABC. And with this triangle, we can use the Heron's formula just by the calculator. And we have the 3 sides, AC, AB, and BC. We just calculate it before in part A. So by the Heron's formula, we have the answer for this triangle ABC. It is 54 cm squared. And then we need to find the total areas. We still have 3, 1, 2, 3, 4, 2 square and 2 rectangle. And at the back, here, at the back over there, we have this one. And we mentioned this as P. It means that we still need to calculate the area of AHPD and then HGFP and then DEFP. And for AHPD, it means this part at the back, this part, and this is the square. We have 10 plus 10. And for this HGPF, and this is the rectangle, 12 plus 10. And for this one, DEFP, it is also the rectangle, 12 plus 10, times 10. So we add 1, 2, 3, and this 3 together, we have the total surface area. And this is 100, and this is 120. This is also 120. So at last, for the total surface area, at this first one, 84 plus 84, this one, and plus 82, this one, and plus 54, this one, and then lastly we plus this 3. This is 200 and 320. We plus 320. And at last, we have the answer. It is 644 cm square. And it finished the part B. And then we have the part C. For the part C, we need to find the angles between the plane A, B, C. It means our blue one. And to the plane B, E, F, G, C, it means the red one. And for this one, we need to find the angles. Firstly, for the triangle ABC here, ABC, we need to find the height of ABC. So we call this M, and here we need to find the height. For the triangle here, AB, this one is equals to AC as we calculated before. And then we have BM equals to MC because this is the isosceles triangle. So we can use the Pythagoras theorem and find out the height of AM. And here we just calculate before AC. It is 6 times square root of 5. 6 times square root of 5. And then BC. For the BC, it is 6 times square root of 2. And half, we just divide by 2. So we use the Pythagoras theorem to find out the AM. It is square root 6, this one square, and minus this one square. And we have the answer, it is square root of 162 cm. And also in the triangle AMV, the triangle AMV here, AM here is the M, AMV here. We can use the sine formula to find out the angle of AMV so that we can find the angle in between. And here in the triangle AMV here, we use this color ANV. And we use the sine formula here, sine angle AMV. That is equals to AV over AM. And we have 12 over square root of 162. And we can find the angle AMV. It is 7.529 degrees. And then we find the angle in between. It means we need to use 180 to minus the angle AMV. It is 7.529. And we have the answer 109.5. And correct to one decimal place. Because at last we need to find the angle over here. The angle over here. So we need to firstly to find out the angle AMV, so that we use the adjacent angle on straight line and find out the angle of AMF. So it finished to find the angle between the two planes.